Hello students, today we are going to discuss the third numerical of strain energy method. Question is written as determine the vertical deflection of point C in the frame shown given E equals to 200 kilonewton per mm square and I equals to 30 into 10 to the power 6 mm to the power 4. Now we need to find the vertical deflection of point C. Now for finding the vertical deflection of point C, we had just made the free body diagram like this, that is A, B, B and C. Now due to this unit load at C, we will have the moment about XX section which will be equals to what? It will be equals to minus 1 into X, okay, that is minus 1 into X of hogging nature, okay. Now at B, due to this unit load at C, there will be a anti-clockwise movement of 3 kilonewton meter. Now due to the equilibrium or due to the joint equilibrium of joint B, we will have a 3 kilonewton movement acting in the clockwise direction here like this, okay. Now if we want to compute the moment about this section, that is XX section, for the span AB, we will have the moment equation here which will be equals to minus 3 because of this 3 kilonewton moment, and because of this 1 kilonewton force there will be no moment because there will be no perpendicular distance for this 1 kilonewton load. So for the portion BC from the origin at C, the limit of this span is 0 to 3 meter and its expression will be equals to minus 1 into x, which will be shown here. Now for span AB, the origin is B and its total limit is 0 to 4 meter and its expression for moment is minus 3, minus is for hogging moment, okay. Now we need to find the strain energy of this frame. It will be equals to 0 to 3 minus of x square dx upon 2ei plus 0 to 4 minus of 3 whole square upon 2ei into dx. Now after solving this, we will get 1 upon 2ei into x cube by 3. The upper limit will be equals to 3 and the lower limit will be equals to 0, and after solving the second expression we will get 1 upon 4ei 9x 0 to 4. Now after solving the whole equation, we will get strain energy equals to 13.5 upon EI. That will be the total strain energy of this frame. Now we need to compute the total work done by the external load here. So the total work done will be equals to what? Half P into delta. Here the value of P will be equals to 1 kilonewton because 1 kilonewton of load will be acting at joint C. So we just write the value of P as 1 and delta as delta. We will get the value of work done equals to delta by 2. Now according to the strain energy method, the total work done will be equals to the strain energy of this frame. So it will be equals to delta by 2 equals to 13.5 upon EI. After solving this, we will get delta equals to 27 upon EI. Now we have the value of E and I. We just compute the value of E and I, and after that we will put the value of E and I here. Now after multiplying the value of E and I, the value of E will be equals to 200 and the value of I will be equals to 30 into 10 to the power 6. Now we want answer in kilonewton meter square. For this we need to convert this by multiplying 10 to the power minus 6. So its value will be equals to 6000 kilonewton meter square, okay. Now we had computed the value of EI in terms of kilonewton meter square. Its value will be equals to 6000. Now we just put this value in the delta equation. It will be equals to 27 divided by 6000 and the value will comes out as meter. So its value will be equals to 0.045 5 meter. But we want deflection in mm, so we need to multiply here 1000 and it will be equals to 4.5 mm. Now we had computed the deflection of the joint C, which will be equals to 4.5 mm in this question. Now we had completely solved this question. Thank you very much, students.